This video is a review of Chapter 3, Lesson 5, Square and Square Roots. Let's review basic vocabulary. In math, when we square a number, we are actually taking a number and raising it to the power of 2. Again, the base is the 4, the power is the 2. When you have a power of 2, a power tells you how many times you're going to multiply a number times itself. So, 4 raised to a power of 2 is equivalent to 4 times 4, not 4 times the power. So, 4 to the second power, or as we say, 4 squared, is 4 times 4, so its value is 16. So, 4 squared equals 16. Negative 4 squared will also have a value of 16, since again, the base is negative 4. The power tells you how many times you are multiplying that number. So negative 4 squared is equivalent to negative 4 times negative 4. And we remember from our rules of operations that a negative times a negative is a positive. So negative 4 squared also has a value of 16. This brings us into the next section of where we talk about something called perfect squares. A perfect square is a number that has two identical factors. For example, 25 is a perfect square because the two factors to get 25 are 5 times 5, or 5 squared. The other factors we can use to get 25 are negative 5 and negative 5. So negative 5 squared also equals 25, making the value 25 a perfect square. So let's review these numbers to see if they are perfect squares. Again, remember, a perfect square is a number who can have two identical factors. So you need to know your multiplication factor. What two identical numbers multiplied times each other will give us 121? Well, 11 times 11 equals 121. Therefore, 121 is a perfect square. Are there any other factors, identical factors, that can give us 121? Actually, there are, because also negative 11 times negative 11 will also give us positive 121. So yes, 121 is a perfect square. Let's look at 200. Now remember, we're looking for two identical factors. What two numbers multiplied times each other can give us 200? Well, there aren't any. Remember, this is not about raising a base and multiplying it times 2. Squaring a number means multiplying the number times itself. So there are no identical factors, two factors we can multiply together to get 200. Therefore, 200 is not a perfect square. Let's look at 400. There are two factors identical we can multiply together to get 400. 20 times 20 is 400, and negative 20 times negative 20 is 400. So therefore, 400 is a perfect square. So a perfect square refers to the value of multiplying two identical numbers. 5 times 5 is 25, making it a perfect square. Negative 5 times negative 5 is 25, making it a perfect square. The inverse of that would be to take the square root of a number to determine what factor is squared to get that value. So the square root of 25 is 5, because 5 times 5 will give you the perfect square. However, negative 5 times negative 5 is also going to give us 25. So therefore, both 5 and negative 5 are the square roots of 25. Perfect square refers to the value after you multiply a number times itself. Square root asks you what number will I multiply times itself to get that value. And although every positive perfect square actually has two square roots, a positive and a negative. Most times in math, we only refer to the positive value, and it has a special vocabulary term of being called the principal square root. So let's do a quick review here of a couple of exercises. So in number 4, they're asking you to find the two square roots for each number. In the first one, and again, remember, square root is what number times itself will give you this value underneath the radical symbol. Remember, this is called a radical symbol. When there's no number there, it's square root. Okay, what number times itself will give us 81? Well, the principal square root, okay, the positive square root here is 9. Now, if you look at example number 2, or part 2 of this number, this symbol out in the front, remember, we've talked about this many times, that's a negative symbol. Okay? It can mean negative, or it can also mean the opposite of. What number is the opposite of the principal square root? Well, since a principal square root is a positive number, its opposite is going to be the negative number. So the two square roots for 81 are 9 and negative 9. Please notice, though, this symbol, this negative symbol, is outside of the radical. Okay? Also over here, it's outside of the radical sign. Outside of the radical sign. I just want to remind you that this is different. Okay? The negative on the outside of the radical sign is very different than if there is a negative under the radical sign. Remember, we talked about this briefly yesterday. Is there any number you can multiply times itself to get a negative value? Again, remember our rules of operations. A negative times a negative is going to give you a positive. A positive times a positive will give you a positive. So is there any number you can square to get a negative value? Well, that answer is no. And if you remember from yesterday, we talked about this type of number is called an imaginary number, right? But we'll get more into that in another lesson. I just wanted to point it out that this negative sign on the outside of the radical is very, very different than if the negative symbol was underneath the radical. Okay, the last thing I want to review here is down here where they're talking about when you have radicals within an expression. Whenever we're simplifying any expression, we always follow the order of operations. And we talked about using the acrostic GEMS, right, for groupings, exponents, and radicals. Then we will either multiply or divide from left to right, or subtract or add from left to right. So in this expression, we have 5 times radical 100. Then remember, when a number is outside of a grouping or next to a radical symbol or parentheses, it means multiply. So the first thing that we're going to do is simplify the radical. So what is the square root of 100? And you're going to use the principal square root only, the positive square root. So the square root of 100 is 10, because 10 times 10 will give us 100. This then continues with the multiplication. And again, following order of operations, we are going to multiply before we subtract. 5 times 10 is 50. Then 50 minus 3 gives us 47. So let's do one quick example on expressions containing radicals. So down here, we're going to look at this and we're going to ask ourselves, where do we start? Well, 3 next to the radical symbol means multiply, but since the radical must be simplified first we are going to say, what is the square root of 144? The principal square root, which is 12, because 12 times 12 is 144. Again, using order of operations, grouping, exponents, multiply, divide, subtract, or add, we are going to multiply before we subtract. 3 times 12 is 36. 36 minus 20 gives us 16. So 3 radical 144 minus 20 will give us a simplified value of 16. Okay, so let's look at the next example. The sign is another expression. So we talked when we learned about order of operations how the radical symbol can also be considered a type of grouping. Whatever's going on under here must be satisfied first before you take the square root. We can also break these two apart, take the individual square roots, and then continue the math. However, what we're going to do here is we are going to continue the radical symbol, and we are going to add 25 and 144 to get 169. So this is asking, what is the square root of 169? Well, the square root of 169 is 13. the principal square root, because 13 times 13 is 169. When we finish simplifying the expression, 13 plus 13 will give us 26. Now let's look at example number 12. Here, again, we have this entire expression, 100 over 25, or 100 divided by 25, because again, a fraction is another way of writing division. All of it is under the radical symbol, which means we need to take the square root of each part. So the square root of 100, what number times 1 itself will give us 100, which is 10, over the square root of 25, which is 5. 10 over 5, or 10 divided by 5, simplifies to the whole number 2. And then 2 plus 1/2 gives you your final answer of 2.5. So the square root of 100 divided by 25 plus 1/2 equals 2 1/2. So as a final recap, in math, when you square a number,